We have a long title on this project. It's AI-based cybersecurity for CAN and IP communication in existing vehicle environment. So the name of the game is to secure vehicles in that sense. So that's what we have tried to do, or at least to detect cyber attacks in vehicles. And there is a huge challenge in the way we develop vehicles today, that we are doing them more vulnerable, and we are creating essentially more attack vectors as well in vehicles when we do them more technological and more digitalized. So what we see is on the baseline you have a CAN bus network in almost every vehicle today, and then on top of that you have an IP network as well. So you have the communication systems, you have video cameras, you have now these days you have video cameras outside, you have inside, you have the entertainment system, you have navigation, all of these things that open up vulnerabilities. And also on the CAN bus you have engine control, you have brakes, you have lights, you have all these systems that are connected to one network. And that makes it a challenge. And in the market that we see today, there will be, at 2023, there will be around 775 million cars connected, which opens up a huge market for this, and there is also a huge need to be able to protect these vehicles, because in essence it can really hurt our society. And ENISA has come up with a report that is Connected Automated Mobility, which it's a report that shows that it's important to be able to use this all advances in the technology to minimize pollution, to have more connected vehicles so we are more efficient, we minimize traffic jams, we can do a lot of good with this technology. But there is also these hazards. So we need to combat all of these threats. And in this project, we have been me from Clavister, we have Brun Innovation, and we have BAE Systems as well, as a kind of like a vehicle provider for us for these tests. And the purpose of the project has been to show that we can detect cyber attacks in vehicle communication. So in essence, we use an AI technology, which I can go back. From the beginning, we were actually 4 participants, but Clavister actually acquired Omen Technologies, which was a startup from Chalmers University, and they research a machine learning software there that we have worked on with this project as well. So that's what we've done. It's kind of like became a little bit of a love story in this project, so that was nice. And the achieved project milestones were in number 1 and 2. We actually did a recording. We had a recording of a data which we learned our AI model, kind of like the baseline of how this vehicle is working. And then in step 2, we ingested cyber attacks and proved that we could detect them. Then in step 3, we also validated a proof of concept in a real vehicle out in the field. So we could also prove that we could detect these new cyber attacks that were deployed then. And now we also are trying to, as a further step, trying to reduce compute resources. So the thing with this AI is that it's super resource efficient. It can be installed on-prem on the vehicle, so it doesn't require a lot of hardware to run. So we're working on that now, and the thing is you don't need to be connected to a cloud, which makes it even more secure and less vulnerable as well. So that's good. And I can show you a demo here about a little bit about the interface, how it works. Can we press the how do I press to start the video? Maybe it doesn't. It's kind of like a video in the presentation. Can we start it just to show a little bit about the demo? Okay. maybe, oh yeah. So then you can see there's an attack, and then you can see from the baseline, you can see a spike coming up. So yeah, and now it goes back to normal. So you can see how we can detect these cyber attacks. And we will also be able to show you a demo from a video game where we have essentially added canvas signals, and then on top of that we have installed our AI engine that runs. So we can show you a simulation of this. And also we have used on events, we have used like a steering wheel and a simulation where you can run it yourself, and then we ingest the cyber attack, and then you run off the road because it says steer to the left or full gas, and you can't do anything about it. And then we deploy our AI on top of that, and then you will just feel like a little bit of a nimble in the steering wheel maybe. That's the difference when we put this protection on. So it's quite cool. And we've seen some spin-offs from this as well, and we see new areas where we can deploy this AI technology all the time. So one spin-off is to integrate it with our firewalls, Clavister's firewalls, to have it as a feature there in our product line. And also we won a tech day competition at FMV Rymd, where we could from the raw frequency signals from the satellites, we could actually prove that you are being jammed, and exactly where you are being jammed, in what wave band, and what frequency you are being jammed. So that's quite interesting. We have a research report from that. If you want to see it, go ask us. And we're also in a project now where we are discussing eavesdropping on fiber optics. So when you bend the fiber, the photons will continue in a certain direction. So if you have a photon detector there, you can listen into the signal and tap it. So we have we are working on a system now to be able to detect when it's being bent to listen in on the signal. And we run our AI model there to be able to do that. And also we have a project with power grids. The context person has been Jenny Roos, Stefan Brodin. I'm here instead of Stefan, and Måns from BAE Systems. And please visit our booth for a demo and go talk to us there. Thank you so much.
Thank you, Jesper.